Right now, something that will change the world's weather is happening. El Nino is waking up. Pacific waters are heating at a rate scientists describe as very rapid. United States forecasters say El Nino will officially form within the next month. The Australian Bureau of Meteorology gives a 2 in 3 chance it becomes strong or very strong by late autumn. Half of European climate models now show one of the strongest El Nino events ever recorded. Pacific sea surface temperatures are projected to reach 2.5 to 3 degrees above average, higher than 1997, higher than 2015. The last super El Nino pushed 60 million people into food insecurity. Indonesia's forests have already started burning early this year. 2024 was the hottest year on record. 2027 is now forecast to break it. But here is the detail that tells the real story. The strongest El Nino in modern records, the 1997 event, peaked at 2.4 degrees above average. The forecasters watching the Pacific right now are not asking whether this one matches it. They are asking whether it crosses the 1877 mark, the strongest El Nino ever measured, in an age before satellites, before climate models, before the modern world existed. And the warning signs say it might. This is what no one told you about the ocean off the coast of Peru. The story does not start in 2026. It starts in 1877, when the strongest El Nino ever recorded sent the Pacific to 2.7 degrees above average and triggered the Great Drought across India, China, and Brazil. Tens of millions died in the famines that followed. For more than a century, that number stood as the worst-case ceiling. Then came 1997, the modern reference event, at 2.4 degrees above average. Then came 2015, the last super El Nino, also at 2.4 degrees above average. Then a long La Nina pause. Then 2023 to 2024, a moderate El Nino, whose tail end alone pushed 2024 into the record books as the warmest year ever recorded. And now, in 2026, the trade winds across the equator have stalled, the warm pool is sloshing east, and the forecasts are climbing past 2.5 degrees above average toward 3 degrees above average. Watch what is moving. The engine sits along the equator in the central and eastern Pacific, thousands of miles of open ocean now warming faster than it should. Trace the heat west to Indonesia, where peatland fires are already smoldering months ahead of the dry season. Trace it south to Australia, where bushfire forecasts are climbing. Trace it east to northern Peru and southern Ecuador, where coastal villages are already being warned to prepare for catastrophic flooding. Then keep going to East Africa, Central Asia, the southern United States, the West African Cocoa Belt, the Middle East Grain Zone, and the United Kingdom, where the Met Office has flagged a raised probability of a colder winter. One ocean, 6 continents on the hook. Here is how it actually works, and it is not the textbook version. In a normal year, the trade winds along the equator blow steadily from east to west. They drag the surface of the Pacific with them, piling warm water up against Indonesia and pulling cold water up the coast of South America. That pile of warm water is enormous, bigger than the continental United States, and it sits there, leaning against Asia, held in place by the wind. When El Nino begins, the trade winds slow. Sometimes they reverse. The mountain of warm water against Indonesia loses its support, and it does what mountains of water do. It slumps. That slump moves east. Slowly at first, then faster, the warm pool sloshes thousands of miles across the open ocean toward South America. When the warm water arrives off Peru, it cannot hide. The atmosphere above the Pacific behaves like an open radiator the size of a continent. Heat that was trapped under the surface now radiates straight up into the sky. The air column above the eastern Pacific expands, rises, and reshapes the entire pressure pattern over the tropics. That is the moment the jet stream bends. Storm tracks that normally cross from Asia to North America shift south. Rainfall patterns that normally water Indonesia move east over open ocean and dump on the Peruvian coast instead. Wind shear over the Atlantic increases, chopping the tops off hurricanes before they can organize. The atmosphere reorganizes itself around the new heat dome, and 4 continents change weather at the same time. That is what is starting now. Listen for what comes next. A smallholder farmer in Sumatra walks his peatland in May and finds smoke already rising. The dry season has not arrived. It is supposed to be the wet half of the year. The fires that normally come in August are coming now. Indonesia has been here before, in 1997 and in 2015. And each time, the smoke crossed borders, grounded flights across Southeast Asia, and pushed children into hospitals with respiratory failure. On the other side of the Pacific, a fisherman in northern Peru pulls his nets and finds them light. The anchovy that drive the entire coastal economy follow cold water, and the cold water is being pushed offshore. He remembers 1997, when the fishery collapsed, the rains came in sheets, and entire coastal towns lost their cash crop and their roads in the same season. Scale up. The United Nations reported that the 2015 to 2016 El Nino pushed more than 60 million people into food insecurity. Droughts hit southern Africa and Central America, floods struck East Africa, and chocolate prices spiked 15% as cocoa harvests crashed in Ghana and Ivory Coast. That event occurred at 2.4 degrees above average. The current forecast pushes higher. Scale up again. The Middle East grain zone is already under heat stress. The West African cocoa belt is already in deficit. The Atlantic hurricane season, the only season that matters for the eastern United States, is forecast to be suppressed, which sounds like good news until you realize the same atmospheric pattern that calms the Atlantic is the one that dries Australia and floods Peru. Every continent gets a different bill. And then the receipt. 2024 was the warmest year in human records. It was set by a moderate El Nino. The event now developing is projected to be much stronger, and the global temperature lag means the heat will peak the following year. 2027 is the new target. The Copernicus Climate Change Service in Europe and forecasters across the United States and Australia are now in alignment on this one point. Next year is going to be hotter than any year humans have ever measured. So what happens next? No one knows whether this El Nino peaks at 2.5, at 3, or at something past the 1877 mark. No one knows whether the Peruvian rains arrive in December or January, or whether the Indonesian fires hold off long enough for monsoon rescue. No one knows whether the cocoa harvest survives, or whether the East African short rains become a flood. What the forecasters do know is that the threshold has been crossed. The warm pool is moving, the radiator is on, and the jet stream is already bending. The Pacific is still heating. The trade winds are still slowing. The warm pool is still sloshing east. The forecasts are still climbing. Indonesia is still burning early. Peru is still bracing. The Met Office is still warning. The Copernicus models are still updating. The Australian Bureau is still raising its alert. And the calendar is still moving toward a winter the Pacific has not seen at this intensity in 150 years. The threshold has been breached, the clock has started, and the year ahead is already being written.